Hi friends, see in alternating currents we discussed already in part 1 up to uh, combination of inductor, capacitor, okay, pure resistor, capacitor, okay, different combinations seen. Now in last case we will be seeing today, that is three combinations. Already I explained regarding the concept regarding three cases, that is uh, first one is pure resistor, inductor, and of course capacitor. So when three of them are connected with AC voltage, that is V is equal to V0 sin omega t or E is equal to E0, anything you can use in this case. Okay, so when three are applied, already I have shown you the diagram. Regarding pure resistor, wherever the current, there the voltage phase difference 0. When inductor is there, current is lagging by pi by 2. So then voltage is leading by pi by 2, current is lagging. In the same fashion, when capacitor is there, current is leading by pi by 2. So this is capacitor. So the same thing I have applied for even the resistance also. Okay, R resistance. Again this is XL pi by 2. Current, resistance means current lagging behind, and here again XC. And I have already given the details regarding what is XC, omega L, which is called as inductive reactance. Inductor is also called as resistance, but it is named because if in the circuit if you use inductor or if you use capacitance, then it is called as XC, which is called as 1 by omega C, called as capacitive reactance. Capacitive reactance. So these are the things when three of them are connected. Here you have discussed three cases also. Case 1, case 2, case 3. Case 1, what happens when VL is equal to, VL greater. When VL greater than VC, you have observed, then the resultant will be in this direction. Okay. Resultant means, what is the final? VL minus VC. Then the V net already I given as V net is equal to root over VL minus VC whole square plus VR square. If suppose VC is greater, suppose if VC is greater than VL, then the V net will be in this fashion, root over VC minus VL whole square plus VR square. In the same way here in the regarding the inductive reactance and capacitive reactance, here also if this is greater, that is if XL is greater than XC, then the resultant will be in this direction, that is XL minus XC, and this is your impedance Z. Okay, this is the phi, and this is given by root over XL minus XC whole square plus R square. In the same fashion, if XC is greater than XL, then the resultant will be in this direction. XC minus XL resultant. So this will be this direction, that is root over XC minus XL whole square plus R square. So different cases were observed. In the same way, from here you can also find impedance, that is cos phi. Cos phi is equal to adjacent by hypotenuse, that is R by Z. Very, very important formula. Okay. So in last case also you have seen if VL is equal to VC, resonance conditions. VL is equal to VC, which is called as resonance condition. So there you have seen omega is equal to 1 by root LC or 1 by 2 pi root over LC. 2 pi is constant, L is inductor, C is capacitance. Okay. So ఎందుకంటే మనకి omega already we know it is equal to 2 pi N or 2 pi F. Anything can use for frequency. So frequency అక్కడి నుంచి ఎంత అవుతుంది 1 by అన్నమాట. ఓకే, ఇక్కడ నుంచి ఫ్రీక్వెన్సీ ఇది. Either F is equal to N, that is 1 by 2 pi root over LC. So all these conditions you have seen, also here also you have seen, when these two are equal, it is equal to pure resistor. Phase difference is equal to 0. So only this thing will be present. Only resistance and current, both will be in the same direction. Phase difference is equal to 0 when both are equal. Clear? So now what we will do is, after discussing about the three things connected in series, okay, Now let us go to the next one, that is LC. Yes, before going to LC oscillations, see one more thing in this case, the phase difference also I can write in this case. I will write you after rubbing this one. Equations kuda maaripotayi meeku, voltage equations current equation, because of these conditions. Voltage as usual V is equal to V0 sin omega t. What about current? I0 sin omega t plus phi ఒకటి minus phi ఒకటి. Okay, when inductor is there, what happened? Current will be lagging by phi equation, and when capacitor is there, capacitance will be, current will be leading by pi by 2. So plus ante when inductor, minus means when capacitor, because reverse this one, inductor. See, for plus what happens? Capacitor leading, current will be leading capacitor, and for minus inductor, L inductor, because current will be lagging behind by phi. Okay, this is the phi angle. Clear? So this is how you can explain the equations also. Now before going to LC oscillations, let us know what is power factor, the very important one. Power factor in the examination is coming in NEET and MCET regularly. What is power factor? See, generally we know in DC current, in direct current we have power V is equal to VI. Okay, that means voltage into current. But in AC, power in alternating current, it is given by what? P is equal to time function, alage current of time function, voltage into voltage of time function into current in time function. You can write in that fashion. Or power average is given by V. What is V equation? Already we are having V0 into sin omega t and I0 into sin omega t plus or minus phi. I will write this one as Vrms into Irms into cos phi. Very important equation. Power, average power is given by Vrms, root mean square, value Irms. See, I you can write either small or capital, nothing is worrying here. And cos phi, here cos phi is called as what? Power factor. Cos phi is called as power factor, please, very important. Cos phi emantam manakada power factor. So phi depends upon the value, whether you give the value 0 or 90 degrees, depending upon plus or minus phi. For example, you know, when pure resistor is there, current will be in the same direction, voltage also in the same direction. Phase difference is how much? 0 between voltage and current. So when phase difference is 0, what is cos phi here? Cos 0 is equal to 1. So what happened to the power average? Average power is equal to Vrms into Irms into 1. So maximum. So power average is given by Vrms into Irms. But we also know V average value. What is Vrms? V0 by root 2 from the before thing. What is Irms? I0 by root 2. So finally what happens? V0 into I0 by root 2 into root 2. So this is the value for power average when only pure, when phase difference and a pure resistor unnappudu, when no inductor and capacitor is there. Clear? So this is the power value. Clear? Now if you observe for the next case, and if suppose inductor is there and capacitor is there, we already discussed about inductor. In the case of inductor the current is lagging by pi by 2 or leading by pi by 2. That means what was the equation? I is equal to I0 into sin omega t minus phi, or I0 into omega t minus pi by 2, or the phase difference. Then the plus or minus omega t minus pi by 2 when inductor is there, plus pi by 2 when capacitor is there. So here leading, current leading, and here lagging current. So in both the cases, what is the phase difference? Phi. phi is equal to ఎంత 90 degrees లేదా pi by 2. So what is cos 90? 0. If you put the value here, what is average power? Power average becomes 0 into this thing. 0. This is also called as wattless current. This is also called as wattless current. No power is consumed. Power is 0. Okay? So when inductor or capacitor is there, cos phi 90 కాబట్టి అక్కడ phi is equal to phase difference ఎంత ఉంది pi by 2 కదా. So cos 90 0 కాబట్టి power average power consumed is 0. No power consumed. Wattless current is called as. Okay? So very important thing in the both the case. Okay? Power is 0 average power. Clear? Right. Now after learning about this one, let us go to the graphs please. Clear? So that is called as wattless current. No power is used when inductor capacitor. Power is 0. This is also called as wattless current. Because power factor మీరు చూసినట్లయితే pi by 2 cos 90 0. And not only that, one more formula is there you have to remember in your brain. Very important. What is cos phi? Adjacent by hypotenuse r by z. This is very important while solving numericals. Okay? That is the resultant. When that means anyhow. For example, if resistance is there, inductor is there, or capacitance. So this is the resultant z phi. Okay? So from this you can calculate tan phi as well as cos. So cos phi is adjacent by hypotenuse. This is impedance value, which is nothing but resistance. Impedance and amount ఎందుకు వచ్చిందంటే is also resistance. Only thing is when inductor or capacitance is connected in the AC circuit. Remember this formula. Now let us go to the graphs please. See, as I told you regarding inductive reactance and inductive capacitance, this is inductive reactance omega L and this is inductive capacitance 1 by omega C. Observe carefully here, XL is directly proportional to 2 pi NL. That means XL is directly proportional to N frequency. That means if you draw a graph on x-axis, that is if you take frequency on x-axis omega, okay, and resistance, okay, and resistance on y-axis, graph ఎలా ఉంది ఇక్కడ చూడండి. ఫస్ట్ directly proportional, you can see resistance, that is inductive reactance, directly proportional to frequency. So it's a straight line passing the origin. ఇదేంటిది XL directly proportional to frequency. But you go to the second case, here XL into the XL XC please. XL కాదు XC. Okay? X is equal to inductive capacitive reactance. This is capacitive reactance please. This is inductive reactance. చిన్న డిఫరెన్స్ ఉంది, జాగ్రత్తగా గుర్తుపెట్టుకోండి. ఇండక్టివ్ reactance XL. This is capacitive reactance when capacitor is connected in alternating circuit. So here if you observe, this XC is inversely proportional to frequency. You can see here XC inversely proportional to frequency. So దీని గ్రాఫ్ ఎలా ఉంటుందండి? So here you can see XC is inversely proportional to frequency. This is directly proportional inductive reactance. Capacitive reactance is inversely proportional to frequency. Okay, clear? So this is the point there. You can mark, and that point is taken as frequency F0. Okay, that is called as F0 value. అదొక మీకు పాయింట్ అక్కడ, right? And here you can take this one as the resistance value, which is you are calling as Z, impedance. You are calling as impedance. See, this is also equal to Z anamata. Adhodna? Clear? So this is how you will be marking the graph between inductive reactance and capacitive reactance. Okay, inductive reactance, capacitive, inversely and directly proportional. You can see there the value is obtained there. Okay, F0 and Z is equal to R, impedance value. Clear? You can take that one as a minimum value. You can take it as minimum value of Z. Okay, minimum value of frequency. Okay, minimum value of Z and resistance and minimum value of the frequency, please. Clear? Now let us go still further. Still further, clear this graph? Okay. Next one. So these graphs are coming in the examination, please. These graphs are coming in the examination regularly. So one more graph I am trying to tell you. One more graph. See here. Origin. Now if you observe carefully, current versus frequency. Current versus frequency. N avachchu, F avachchu. Frequency, same thing. Okay, frequency you can use N and F. Now if you observe this graph, the graph will be like a mountain. Current versus frequency here. So here I naught, I naught is equal to V naught by Z, resistance impedance. Peak value of current is equal to V naught by Z impedance. So this is the maximum value, I maximum. This value is called as I maximum. I maximum, peak value. Okay, and for that one maximum frequency F naught. In the same way, if you take second point, this is half of the value. Half of the value. Second point, if you take, this is half of the value, this one. Half of the maximum current. Okay, na? So maximum current, maximum frequency. If you take frequency on x-axis and current values on the y-axis, you will just get like a mountain, please. Chinna mountain la vastundi graph meeku. Peak value of the current and frequency, maximum value, F naught. Clear? Now let us see one more important thing regarding the power and frequency. In the same graph I will try to explain. In the same graph. I will try to explain the same graph. Suppose if I take on x-axis as frequency, angular frequency on x-axis, and power and y-axis if I mark it, this will become maximum power P max, and this will become half of power value, and these two if you mark it, these 2 points you can mark it as omega 1, omega 2. Okay, these are the frequencies. Omega 1 and omega 2 are called as half power frequencies. Identi half power frequency. This is also half power frequency. Okay, and the middle point you can take it as omega naught. Okay, omega naught. That you can call it as resonance frequency. You can call it as resonance frequency. Resonance. There you already told you what is resonance. There omega L, voltage, that is VL is equal to VC. XL is equal to XC condition. Now in this case you can find out what is omega 1 and what is omega 2. That is half power frequency. So ఎలా వస్తాయి omega 1? How to get omega 1? You can see here. You can also call omega 2 and omega 1. What is omega 1? Omega 0 minus. And this value is nothing but R by 2L, please. This value is R by 2L. R by resistance by inductance value, 2L. Same equal value, R by 2L, R by 2L width. Okay? Now from this you can calculate what is omega 1. Omega 1 is equal to omega 0 minus this value. That is resonance frequency value minus this. You can see this value minus this is equal to omega. That is omega 0 minus R by 2L, omega 1. Alage omega 2. Next frequency, omega 2 ఎంత అవుతుంది? Omega 0 plus R by L. omega 0, that is resonance frequency plus r by 2l. So from this, if you find difference, what happens? Omega 2 minus omega 1. ఎలా చేసినా పర్వాలేదండి. Omega 2 minus omega 2 minus omega 1 is equal to 2 times యాడ్ అప్ అయిపోతుంది. ఓకేనా? దిస్ మైనస్ దిస్ కదా, ఇది మైనస్ అయిపోతుంది. ఇక్కడ వేద్దాం. దిస్ మైనస్ దిస్ ప్లీజ్. I'll write it like this better for understanding. Now if you get the bandwidth delta omega is equal to omega 2 minus omega 1. So ఇప్పుడు మైనస్ చేస్తే ఏమవుతుంది? omega 2 minus omega 1 delta omega is equal to this minus this. Omega 0 plus r by 2l minus of omega 0 minus r by 2l. So omega 0 plus r by 2l minus omega plus r by 2l. Minus this cancel, 2r by 2l, that is 2r by 2l. So bandwidth delta w is equal to r by l. This is bandwidth frequency. Okay na? So which is equal to r by l. See, this is how you can find out the values from the half power and maximum power. Frequency values on x-axis if you take it. Okay? Clear? Right. Now let us go to copy. Let us go to the last one, that is power factor, quality factor. Quality factor, please. Quality factor. Clear? Right. See, these graphs are very, very important in understanding the concept in numericals. Now what is quality factor? What is quality factor? Capital Q. Okay? So quality factor, that means sharpness of the resonance. How sharp it is? Sharpness of the resonance. So how sharp it is? Ela depend avutuntundi, which is sharper? That is also again from the graph you can locate. See here. Again I am drawing the graph. So quality factor again depends upon the graph sharpness. See here. For example, if I take a graph again, P versus omega, again same, P versus power versus frequency. This is one graph. Okay? And this is another graph. Suppose this is first resonance condition and this is second resonance condition. Now if you observe, second one is more sharper. Second is more sharper than first one. This is more sharp, you can see. More sharper. Okay? So because it is more sharper, what happens here? Here what just now I tell you what is delta W? Omega 2 minus omega 1. The bandwidth emavali should be smaller. Bandwidth ఏదైతే RL ఉందో మీకు R by L వచ్చింది కదా, R by L should be smaller. So when the bandwidth is smaller, what happens? Sharpness will be the resonance. Resonance will be more sharper. Okay? So delta W should be more less. దాన్ని బట్టి మాకు ఏమవుతుంది? Resonance will be more sharper. Therefore, quality factor Q is given by angular frequency omega naught resonance, okay, by delta W. ఇదేంటి తెలుసు కదా? Resonance frequency by bandwidth. So quality factor Q is equal to ఇదేంటి? ఆల్రెడీ మీకు మొన్న చెప్పాను కదా. What is omega naught? 1 by root LC. So 1 by root LC, I'll write it like this, root L into root C. Okay? By delta W. ఇప్పుడే వచ్చింది. What is delta W? R by L. So here you know already delta W R by L. So this one goes like this, 1 by L power 1 by 2 root C top L by R. L power 1 by 2 పైకి తీసుకెళ్తే L power minus half into L by R into root C. L power 1, L power minus half, 1 minus 1 by 2, that is equal to how much? 2 ones are 2 LCM, half. So L power half by R root LC. So ఇది ఫైనల్ ఏమవుతుంది మనకి? This is nothing but what? Root L, L power half by R into root C. So finally you are getting quality factor Q is equal to ఏమొచ్చింది 1 by R into root over L by C. That's all. This is the quality factor formula. 1 by R resistance into root over inductor value by capacitance value. So when you take the graph again, power versus omega, that is angular frequency. So delta W should be as minimum to get more sharpness in the resonance. Okay? Clear? So this is how we will be explaining the things. And last one, LC oscillations. And please copy this one. Please copy it. Right. Now last one, LC oscillations. LC oscillations. See, LC oscillations and ఏమీ లేదండి, very simple and try to explain. Very important. Detailed oscillation దీంట్లో మన examination లో just will be asking what are the formulas in that one. In LC oscillations, if you see LC oscillations, okay, that is inductor and capacitor will be in the circuit. Inductor and capacitor. Inductor, capacitor, inductor. So in this case you can see sometimes it will be like this. Charge will be in this direction, field. Okay. And this is what? See here both the cases are there. Magnetic effect ఉంటుంది, magnetic effect and electrical effect. And electrical effect. Both effect will be there. Two energies will be there. Here electrical energy will be there. Electrical energy, that is UE and UB. Okay. So how will you get electrical energy? Total energy ఎలా వస్తుంది? Total energy is nothing but electrical energy plus conservation of energy. Electrical energy plus magnetic energy. That is due to the inductor. That is nothing but what? Q square by 2C plus half Li square. So these both energies are there here. Inductor energy and electrical energy. Inductor energy ante ikkada UB. Magnetic energy plus electrical energy. Q square by 2C plus half. Sometimes this may be 0. This will be present. Total energy. And sometimes this will be present, electrical energy. And this may be 0. But total energy is conserved again. Energy is conserved. On the base only, this will be functioning. The growth and decay. See, the growth of current and decay. Okay, decay means coming down. So it depends upon these values. But total energy is constant. Q square by 2C plus 0 or Q square by 2C plus half Li square. Energy stored in the inductor. This is energy stored in the inductor, please. Okay. So both the things, in this way the things are LC oscillations are going on in this circuit. Total energy is conserved andi. L, energy of the L and energy of the capacitance. Okay. Q square by 2C, half Li square. Once this is becoming 0, that will be present. Inductor energy. Inductor energy 0 అయినప్పుడు capacitor energy will be there. So in this way the energy is conserved. And LC oscillations are going on. Clear? Any doubt? So LC oscillations are everything explained cheyachandi. Very easy concept. Nothing to worry at all. So just simply it's a conservation of energy. Conservation of energy, oscillations. Inductor energy and capacitor energy. Okay na? Now I am coming to the last point in this chapter to end up. That is nothing but transformer. Transformer. See, you all know the basic structure of a transformer. We all know the basic structure of a transformer. So in this way, if you take, these are the laminated sheets arranged inside transformer, laminated sheets, soft iron core, dotted line soft iron core, and here the number of turns, okay. Let the turns be in the primary coil be NP or N1, okay. Here NP, number of turns in the primary coil, and NS, number of turns in the secondary coil, as this one. So this is the main thing, okay. So this one you can take it as sometimes N2 also, N2 or NS, this one N1 or NP. Here EMF E1 or V1 voltage, here E2 or V2, here current I1 or IP primary, here I2 or I secondary. So these are the initial things, the basic structure of a transformer. And what is the definition of transformer? Transformer, mainly how it functions. In general, you can see outside on the roads, you can see so many transformers are there. Those are generally called a step down, not step up. Step up are used in industries because more output is required. So transformer function enti, it increases or decreases the alternating current voltage. Already I have shown in the before, increasing and decreasing the voltage continuously, okay, by using the mutual inductance of two coils. That is the basic phenomenon. By using mutual inductance of two coils and using Faraday's laws. So transformer is nothing but it is a device continuously increasing and decreasing the alternating voltage by using the mutual inductance of two, increasing or decreasing the alternating current voltage by using mutual inductance of two coils. That is the base. You can see two coils are there, primary and secondary. And here the current is I1 in primary, I2 or IS, IP. Alaga voltage V1, V2 or VS, VP. You can also call it as EP primary or E secondary. Now what we will do is, after explaining, we will apply Faraday's laws here. We will apply Faraday's laws for the first one, coil. Apply cheste, according to the Faraday's law, what is the first one? Induced EMF is directly proportional to rate of change of magnetic flux. Which coil? Primary coil. Okay. So here what induced EMF and E1 or primary, anything you can take, primary or E1. Okay. So now remove the proportion, introduce a constant K. If number of turns are there, N turns. If number of turns NP. Number of turns NP. So d phi P by dt. Equation 2. In the same way, apply Faraday's laws to the second one. Induced EMF is directly proportional to, minus will be there due to Lenz's law, minus into d phi secondary by dt. Again, suppose here, this one you can take 2 or secondary. E2, removing the proportion, introduce a constant K, minus will be there, Lenz's law, and number of turns, N2 or NP or N secondary, into d phi secondary by dt, 3. Okay, now divide equations both. Divide equations, E1 by E2 or E2 by E1, anything is okay. E1 by E2 or E primary by E secondary is equal to, when you divide, what happens? See there, E1 NP d phi dt by N secondary d phi secondary by dt. So this gets cancelled. Em migultundi manaki? E1 by E2 is equal to NP by NS. Very, very important one, formula. So here EMF for voltage is directly proportional, you can see. NP and dt, N1 kada, number of turns here. Directly proportional to the number of turns. More turns, more EMF, more voltage. Okay. Now if you observe carefully, one more thing. I am rubbing this one. If you observe carefully, for example, take ideal transformer, ideal. What is an ideal? In general, it won't have ideal, just for explaining. In ideal transformer, ఏమవుతుందంటే power output is equal to power input. In ideal transformer, output power is equal to input power. What is output power? Power formula ఏంటి? VI. So output power అంటే ఎంత? E2 into I2. I2 అంటే ఏంటి? Secondary current is equal to power input. Input means E1 into current I1 or IP. Okay? So in this what happens again? You see this equation. What is E1 by E2? E1 by E2 is equal to ES by IP. So on the equation alone. Here EMF is inversely proportional to the current. More current, less EMF. Okay, less current, more inversely proportional. E1 by E2 is equal to ES by EP. Substitute here. So E1 by E2 is equal to NP by NS is equal to E1 by E2 IS by IP. This formula is very important in solving numericals. Inversely proportional to current, directly proportional to the coil. Directly proportional to the number of turns. Inversely proportional to current. More current, less this thing. You can see. E1 or E primary. Inversely proportional. Clear? Right. Now, ideal అనే మాట మీకు ముందే చెప్పాను. ఐడియల్ అనేది ఎక్కడ ఉండదు, ఓన్లీ ఫర్ ఎక్స్ప్లెయినింగ్ ఐమ్ టెలింగ్. ఐడియల్ ట్రాన్స్ఫార్మర్ అంటే పవర్ అవుట్పుట్, నో పవర్ లాసెస్ అనమాట. మినిమం పవర్ లాస్ ఉంటుంది. Now next thing, we'll see what is transformer ratio. Very important. Transformer ratio. Okay na? We are coming to the end of the chapter almost. Transformer ratio అంటే ఏంటో చూద్దాం. What is transformer ratio? Transformer ratio is nothing but NS by NP or N2 by N1 is equal to K or ఇది NS, number of turns in secondary by number of turns primary. N2 by N1 is equal to K. Okay? Suppose if N2 by N1 is equal to 1, for an ideal transformer, we'll take K is equal to 1. అప్పుడేమో N2 is equal to N1 అనమాట. అలా కాకుండా if K value is less than 1 or greater than 1, you can tell that this transformer is step up or step down. For example, K less than 1 తీసుకుందాం. For example, see here. N2 by N1 is equal to half తీసుకుందాం. అప్పుడు ఎంత అవుతుంది మనకి? N2, 2N2 is equal to N1. జాగ్రత్త చూడండి, ఇక్కడ ఈక్వేషన్ వస్తుంది. We'll try to explain. See here. I'll take these two equations now. E1 by E2 is equal to NP by NS. NP means number of turns. So from this what I'll do, I'll try to take E2. What is E2? E1 NS is equal to E2 NP or E1 into NS by NP is equal to E2. చూడండి, E1 into NS by NP. So what is E2 here? Output voltage. So for household purposes, in domestic, output is minimum మనకి 250 volts చాలు, 260 చాలు పవర్, అంతకన్నా ఎక్కువ అవసరం లేదు. బికాస్ ఐటమ్స్ విల్ బి స్పాయిల్డ్, ద టీవీస్ అండ్ అదర్ రిఫ్రిజిరేటర్స్. సో 250 వోల్ట్ అంటే అవుట్పుట్ తక్కువ రావాలి. అంటే బిఫోర్ కమింగ్ ద వోల్టేజ్ ఫ్రమ్ ద ట్రాన్స్ఫార్మర్ టు ద ఇన్సైడ్ హౌస్, ద వోల్టేజ్ షుడ్ బి స్టెప్ డౌన్. సో స్టెప్ డౌన్ అవ్వాలంటే ఏంటి? అవుట్పుట్ వోల్టేజ్ షుడ్ బి లెస్. వెన్ దిస్ విల్ బి లెస్? వెన్ దిస్ వాల్యూ షుడ్ బి వాట్? NS ఏమవ్వాలి ఇక్కడ? అవుట్పుట్ తక్కువ ఉండాలని ఏమవ్వాలి? షుడ్ గెట్ లెస్సర్ వాల్యూ. NS should be less than NP. NS should be less than NP. Number of turns in the secondary coil should be less than primary. చూడండి ఇక్కడ. If this is more value, what happens? You'll get more value from denominator and numerator method. ఈ వాల్యూ తక్కువ ఉండాలి NP కన్నా. NS should be less than NP. NS should be less than NP. Then only it is called as step down transformer. Step down transformer. Then output will be less. In the same way, if suppose opposite, if NS is greater than NP, ns అంటే నెంబర్ ఆఫ్ టర్న్స్ ఇన్ ద సెకండరీ కాయిల్. ఇది మోర్ అయితే ఏమవుతుంది, యూ విల్ గెట్ మోర్ వాల్యూ. సో ఇఫ్ అవుట్పుట్ ఈజ్ మోర్, then it is called a step up transformer, which is used in industries. More current is required, around 100 amperes. So industries లోని స్టెప్ అప్, ఇన్ డొమెస్టిక్ లో స్టెప్ డౌన్ యూజ్ చేస్తారు. సో ఇక్కడ ఏమవుతుంది, ఇఫ్ ns is greater than np, number of turns in secondary, then what happens, you will get more value, output is more. So this is called as step up transformer. So this is how you can differentiate between step down and step up. Step down and output is down, getting less value output. Less value and ns should be less than. If ns is greater than, it is step up. Okay, it is called as step up transformer. If ns is more, what happens, output is more. And of course inversely proportional current, more emf, less current. అర్థమవుతుందా? రైట్. The last one and efficiency. Efficiency of the transformer. Generally, in any case, efficiency is defined by power output by power input. ఎక్కడైనా సరే efficiency ఎలా డిఫైన్ చేస్తాం, power output by power input is defined as efficiency. Efficiency of a transformer eta is given by power output by power input. Clear? So power output అంటే ఏంటి మీకు తెలుసు కదా, V2 I2. VA, what is power formula? Power is equal to VA కదా, V2 I2 అంటే secondary current by power input V1, that is E1 into current in the primary. Okay, so power output by power input is called efficiency. Okay, so this is how you can define the efficiency, power output by power input. Very important formula. In the examination they are asking regularly, efficiency of the power. Okay, so it is also given into 100, please, into 100. This is the formula. Okay, so efficiency is given by eta, or what is power output by power input into 100. Power output by power input into 100. This is the exact formula for efficiency. Power output by power input. Power output means what? Output power VI, V2 I2. Power input V1 I1. Okay, E1 into IP. Primary into 100. Clear? In general cases ఏం చేస్తామంటే, ideal will be taking 100%. Ideal is only imaginary, not real. But in ideal case, the efficiency is taken as 100%. No power losses will be there due to heat. Okay, clear? Only in ideal case it is taken as 100%. Clear? Right, Andy? So this is how you have to explain the chapter, and you have to understand various things I have explained in the alternating current in part 2. In part 1 also I derived so many equations. Please try to understand the subject, then only you can do so many problems. Again we will be meeting in the next chapter, please.